This is the vocabulary for lesson 4.4, standard form, numbers that do not contain exponents. So these two numbers are written in standard form, 12,760,000. And the second example is 1,276 hundredth millionths. Scientific notation is a number that is expressed as a product of a factor and a power of 10. So here are some examples of numbers written in scientific notation and how we take them out of scientific notation. I will explain more when we do the lesson. Notes 4.4 on scientific notation. Express numbers in standard form and in scientific notation. Compare and order numbers written in scientific notation. The Common Core state standards are listed in the mathematical practices. A number written in scientific notation is written as a product of a number between 0 and 10. So your digits before the decimal have to be the digits 1 through 9, and a power of 10. Multiplying by a positive power of 10 moves your decimal point to the right the same number of places as your exponent. Express each number in standard form. So the numbers written here are in scientific notation. It's a product of a number between 0 and 10. So we can see that 7 falls in between 0 and 10, and a power of 10. So take your number out of scientific notation. We want to look at your exponent. If your exponent is positive, you want to move your decimal point to the right. So we're going to start by taking your digits in front of your multiplication sign. We're going to put our pen on the decimal point, and we're going to move your decimal point to the right 6 times. 1, 2, 3, 4, 5, 6. Now your decimal point's at the end. We're going to fill in zeros, and we're going to rewrite our number put in commas, and our number written in standard form is 7,821,000. Number 2, 8.65 times 10 to the 5th power. We look at our exponent. It's positive. We want to move our decimal point to the right. So rewrite your number. Put your pen on your decimal point and move your decimal point to the right 5 times. 1, 2, 3, 4, 5. Decimal points at the end. Fill in zeros and rewrite your answer. Put in commas, and we have 865,000. So that number is written in standard form. 3.13 times 10 to the 7th power. Look at your exponent. It's positive. We move our decimal point to the right 7 places. So rewrite your number. Move your decimal point 7 places to the right. 1, 2, 3, 4, 5, 6, 7. Your decimal point's at the end. Drop in zeros. Rewrite. Put in commas. And our answer is 31,300,000. That's your number written in standard form. Number 4, 4.9 times 10 to the 4th power. We have our exponent of 4, so it's positive, so we rewrite our number. The 4 tells us move our decimal point 4 places to the right. 1, 2, 3, 4. Decimals at the end. Drop in zeros. Rewrite. Put in your commas. And we have in standard form 49,000. Multiplying by a negative power of 10 moves your decimal point to the left the same number of places as the exponent. So this time with a negative exponent, we are moving our decimal point to the left. So we have 8.3 times 10 to the negative 5th power. The negative 5th power tells us we move our decimal point to the left. So rewrite our number, and this time we're going to move our decimal point to the left 5 places. 1, 2, 3, 4, 5. Decimal point is now in the front. We drop in zeros. We rewrite it. And this is 83 millionths, written in standard form. Number 6, 9.12 times 10 to the negative 4th power. The negative tells us we move our decimal point to the left. So we rewrite our number. Put your pen on your decimal point, and we go to the left 4 places. 1, 2, 3, 4. Our decimal point is out in the front. We rewrite it. And we have 912 millionths. That's our number written in standard form. Number 7, 3.6 times 10 to the negative third power. The negative third power says we move our decimal point to the left. Rewrite our number. Put your pen on your decimal point, go to the left 3 places, drop in zeros, rewrite it, and we have 36 10,000ths. This is our number written in standard form. Number 8, 1.26 times 10 to the negative 6th power. The negative 6 tells we move our decimal point to the left. Rewrite our number. Put your pen on your decimal point and go to the left 6 places. 1, 2, 3, 4, 5, 6. Drop in zeros. Rewrite. And our number written in standard form is 126 millionths. Express each number in scientific notation. So the next 4 examples have our numbers written in standard form, and we're going to turn them into scientific notation. Number 8 says 123 million. We want to take this number and turn it into scientific notation. We want to eliminate all the zeros so it's easier to read. So remember, we want to eliminate the zeros. It's a number between 0 and 10 and a power of 10. So take your numbers that are written before the zeros and rewrite them and multiply it by a power of 10. Right now, we have 123. That number's bigger than 10. If we put our decimal point after the 12, it's still too big. Our decimal point has to go after the first digit, 1.23. So the 1 falls between 0 and 10. Now we count up where our decimal point was at the end to see how many places we go till it falls behind the 1. 1, 2, 3, 4, 5, 6, 7, 8. So our final answer is 1.23 times 10 to the 8th power. Number 9 is 375 10,000,000ths. This is a very small number. We want to write it in scientific notation. We want to eliminate all the zeros. So we're going to take our 375, put it out in front of our multiplying by a power of 10. So right now we see 375. We need to put it after the 3 because 3 falls between 0 and 10. After the 7 would still be too big, it would be 37. Now we go to our decimal point and we want to count till it falls behind the 3. 1, 2, 3, 4, 5. So our decimal point falls behind the 3. We moved 5 spots. Since it's a really small number, it's to a negative 5. So it's 3.75 times 10 to the negative 5th power. Number 10, 3,240,000. So start by writing your digits that are not 0 and multiply it by a power of 10. Go to your end where your decimal point is and move it to the front until it falls between a number between 0 and 10, which would be your 3. So it's 3.24 times 10 to the 6th power because we moved our decimal point 6 places, so it falls behind the 3. Number 11. We have 468 millionths, so rewrite your 468 times 10 times 10. We move our decimal point 1, 2, 3, 4 places. So our number in front of our multiplication is between 0 and 10. And we moved 4 places. Since it's a really small number, it's going to be a negative exponent. So 4.68 times 10 to the negative 4th power. Compare and order numbers. To compare numbers in scientific notation, you compare the exponents. If the exponents are positive, the number with the greatest exponent is the greatest. If the exponents are negative, the number with the least exponent is the least. If the exponents are the same, compare the factors. Compare each set of numbers using less than, greater than, or equal. Number 1, 2.097 times 10 to the 5th power. We want to compare it to 3.12 times 10 to the 3rd power. In this example, we're going to compare the exponents. They have different exponents. Since the 5 is greater, the 2.097 times 10 to the 5th power is the greater number. We can also take it out of scientific notation so we can compare. And you can see when it's in standard form that 209,700 is greater than 3,120. Number 2. 8.706 times 10 to the negative fifth power and 8.809 times 10 to the negative fifth power. The exponents are the same, so we're going to compare our factors. So we can leave it in scientific notation. We can see that our numbers in the ones place is the same, and the tenths is where they're different. Since the 8 is larger than the 7, that means that's our greatest number. So 8.706 times 10 to the negative fifth power is less than 8.809 times 10 to the negative fifth power. We can also take it out of scientific notation to compare. And we can see that it's the same place value, and the 7 and 8 is where they're different. Order each set of numbers from least to greatest. Number 4, 6.9 times 10 to the third, 7.6 times 10 to the negative sixth, 7.1 times 10 to the third, 6.8 times 10 to the fourth. So the first thing we can look at is compare our exponents. Since our exponents, we have a negative exponent, that's going to be our smallest number. We also have 2 that have to the third power and 1 to the fourth power. So that means that the 1 to the fourth power is our largest, so that's our fourth number. Now we're going to compare our 2 numbers that have the same exponent. So we have 6.9 and we have 7.1. Since 6 is smaller than 7, that goes second. And then the 7.1 times 10 to the third power. Number 5, 4.02 times 10 to the negative 8, 4.15 times 10 to the negative third, 4.2 times 10 to the second, and 4.0 times 10 to the negative 8. The first thing that we want to do is look at your exponents. We have 2 that have negative 8. Those are our smallest ones compared to negative 3 and our positive 2. So we want to compare our numbers. We have 4.02 and 4.0. When we line up our digits to compare, we can see that our 0 is the smallest, so that number is going to go first. And then the 4.02 times 10 to the negative 8. Now we have our negative 3 and our positive 2, so our negative 3 power goes next. And our positive power of 2 goes last. It's our greatest value.